Welcome, listeners, to episode 5 of the Security Simplified podcast. Joining me is my good friend, Ryan Cloutier. Ryan, say hi.
Hi, everybody. Thanks for tuning in.
Absolutely. So, if you remember last episode, episode 4, we talked about, we gave people, the listeners, I think a simple introduction to the OSI model. When we're talking about networking basics still, we've got maybe, I don't know, 2 episodes left of that, and then we're going to switch gears into something different. Tonight, we're going to talk about TCP IP. So, depending on where you're at on the technology spectrum, to some of you, probably all of us have heard TCP IP before or IP address. Uh, some of us don't know what that is. And some of us maybe are intimidated to even ask the question. So, we're going to tackle that one tonight. We're going to tackle what is an IP address, why it's important, um, how to change IP addresses. We'll talk a little bit about routing. We'll talk about DNS resolution. All those goodies. So, what do you think, Ryan?
I think this is a good topic. I'm looking forward to getting into it tonight.
All right. Well, let's start with what is an IP address. I'll let you start, and then I'll make myself look smart by sweeping up the mess.
I like it. So, an IP address, I like to think of it as a telephone number or a street address for a computer. So, it's the way that I identify the specific number of the specific computer I'm trying to connect to. So for example, when I go to www.google.com, I'm using DNS. And what DNS is doing is it's looking to see what IP addresses, what individual computers might respond to that name. And then when it finds the one that is the best connection for me, it connects to that specific IP address. So like at
Yeah, like
home, you have a 192.168.1.1 or 0.1 or 10.1 address. That's a private address for your home. And there's public addresses. Now, Evan can be smart and tell us all about that.
well, this is my jam, man. When we wanted to start the Security Simplified podcast with the first handful of episodes with networking, I was like, oh yeah, that's my jam. But yeah, you're right, man. So we talk about TCP/IP. We use tons of acronyms in our industry. TCP is Transmission Control Protocol. Protocol, again, like I said in a couple of podcasts, is just a language, right? The rules for communication. So TCP is a protocol. IP is also a protocol. It stands for Internet Protocol. Put them together, TCP/IP, it's actually a suite of protocols. We just kind of combined everything into this TCP/IP, right? A whole conglomeration of protocols and rules. Now, IP itself, the Internet Protocol, we talk about an IP address. Like Brian said, it's an address. It tells other computers how to talk to my computer. When I talk to other computers, I can tell that computer where to send the data back to. So we have things like source address and destination address. So if my computer wants to talk to another computer on the network, I'll attach my source address. I'll address the data or the packets to the destination IP address. So when it goes out on the network, only the system that has that IP address that it's, I guess, destined for will respond to it. Now, there's a whole bunch of things that happen below that. An IP address is known as a logical address, which means it's easy to change. You change it in software. So you can go into your computer settings, your system settings, and change your IP address. You can get your IP address automatically assigned to you by, maybe an administrator who set up a DHCP server that just distributes IP addresses and keeps track of who has what IP addresses on the network. So you can set it up, that's called a dynamic IP address. When I set it myself, hard code it, that's called a manual IP address. But yeah, like you said, it's how it keeps order, right? The rules about how these computers are going to be talking to each other. So who sent what and who am I supposed to respond to and all that good stuff. I kind of wish we had IP addresses when we talk at like a party. You go to some of these um,
Well,
party or a
we
social
kind of
gathering,
do.
and everybody's just kind of yapping. I can't. Women are better. My wife is much better at keeping track of the source address of those communications than I am. I'm like, who said what? Anyway, yeah, works like that. So if you want to get technical, right, an IP address is 32 bits broken up into what are called 4 octets. So broken up into 4 8-bit numbers, right? That's how the address is formatted. So when Ryan said 192.168.1.1, the first octet, 8 bits, is 192. The next octet, the next 8 bits, 168, and then 1, and then 1. Computers don't speak decimal, right? They speak binary. They speak binary and hexadecimal, but this base 10, 1 through 10 numbering system, that doesn't work for computers. So this IP address is a human readable number, but the computer will break that down when it's using the network into bits. Yeah, I could keep going, man. Should I keep going?
I mean, I think that's good. I'll give everybody a little history on this real quick. So, TCP IP it came out of a research project at DARPA, Department of Army Research and Projects. They were looking for a way to have secure communications between different military bases. They wanted to connect the computers together. This was called ARPANET, precursor to the internet. And through the work that they did, they developed these protocols. So what's fascinating is we
Well, and
run
one
the
thing I just
modern
want to point
world.
out, real quick, because we can have this, the conversations are always good. We said secure communications. What was really key back then was resilience, right? Was making sure that the network communications would continue to go on, even if there was a disruption. Now, not the definition of secure when we think about keeping things secret. That wasn't part of TCP/IP, right?
Correct, correct. Um, so the point I was going to make about why I brought that up is that we're running our modern world on a technology pioneered in 1973. So it's important to know this because it's still there. And there's two versions. We should talk about that, IPv4 and IPv6. And the reason for that was there was a point where the octets that Evan described run out. There are more devices that need an address, and we're limited to that 10 base, right? There are limitations within our modern computing that prevent us from using that same method to go beyond the maximum amount of characters that you can possibly have in an IP address. I'm pretty sure Evan knows that number off the top of his head. I'd have to Google it. But so they created this thing called IPv6. And IPv6 is a different way of describing that address. So instead of using 192 and 168 numbers, it uses a combination of letters organized in groups of two. So the thing is nobody likes it. It's poorly implemented, and so a technology was created called NATing, or network address translation, which allowed us to keep using that old 1973 tech and adding as many devices as we want, and then we virtualize networks and so on and so on. So you can have many IPs within a single physical network card.
Yeah, absolutely, man. And yeah, the number is so being binary, everything is 2 to the power of something, right? So if I have one binary space, it's 2 to the power of 1, right? So the maximum number of numbers I can have is 2. When you do, 32 spaces, so if it's 32 bits long, 2 to the power of 32 is the entire IP address space. So that's the number. And the number is 4 billion ish, for something like that. I can't remember the number, but 2 to the power of 32. So 2 times 2 times 2 times 2, 32 times. That's your number. But yeah, like you said, we were running out of IP addresses. The Internet Assigned Numbering Authority, IANA, is the organization responsible for tracking and sort of giving out public IP addresses. And, in the early days, we just never thought we'd ever run out. So we just gave them away like, M&Ms. And then we were starting to run out, and like, oh crap, we have to pull a lot of those things back. And then we came up with a new RFC. An RFC is request for comments. So if you Google RFCs, requests for comments are really what govern how TCP/IP works, govern much of how the internet works. And the reason why TCP/IP version 4, the one we all use basically, is still around is because it's very, very fundamentally sound. It's not secure, meaning it wasn't built in with confidentiality built into it, but it's super resilient. I mean, the original inventors of the protocols, absolutely brilliant pioneers, in our industry. Another part of the IP address that you might see. So, and if you ever want to see your IP address, we've mentioned this before on this podcast, on Windows systems, get to a command prompt if you know how to. You can just click on the Windows whatever, and in the search hit CMD, and you'll bring up a command prompt. And at that command prompt, just type in ipconfig, ipconfig. That'll bring up your IP address. Now, for your IP address for every network interface card you have. So if you have a bunch of network interface cards, you'll have a bunch listed there. But you'll also see another thing called the subnet mask. Now the subnet mask really tells the computer what part of this IP address is assigned to the network that I'm on, and what part of this IP address is assigned to my specific system on that network. And the reason why that's important is because you communicate all the time with tons. You open up a browser, you go to Google. Google is not on your local network, right? There's a number of hops or routers that the traffic has to traverse to get from your home or your work to Google's DNS server, resolve that name, and eventually get to Google.com. The subnet mask says, essentially, if it's addressed to something that's outside of this network, send it to the default gateway. And that'll be another number that you'll see when you do an IP config is your default gateway. That's the router's address, right? So when I want to talk to Google, my computer's first going to say, well, is this destined for my local network? Or is this destined for a remote network, a network somewhere else, right? And if it's somewhere else, well, then I'm going to send this with the destination address, essentially of the subnet, of the router. So then the router knows, okay, I'm going to take it from here. I'll hand it to the next spot, the next hop, the next hop. Eventually it gets to where it needs to go, and then it routes all the way back to you, and then that traffic goes back and forth across those hops. It happens so fast, you as a user don't even notice that's happening, but it's happening, and it's happening very, very quickly. The plus is it's very resilient, right? It's going to work for you unless you have some sort of disruption on your network or some misconfiguration, something like that. The not so good thing is every single one of those hops, every single one of those network segments, every single one of those traversals is an opportunity for an attacker to insert him or herself into your network stream, your network traffic, and see what you're doing, right? Or hijack it, or God knows what. Yeah.
Yeah, that is the downside, right? Is sometimes those sites that we go to are malicious or connected to an IP that belongs to a bad actor, and so. But we are getting close to our time tonight. Any closing thoughts on TCP/IP?
No, you're not going to master it, in 15 minutes, in a 15-minute podcast. But hopefully, what this has done is for people who this was just a complete mystery to, maybe it's not as much of a mystery anymore, right? We provided some value to you in that. For those of you who do want to become, experts at these things, maybe we've piqued enough interest in your mind to go and become an expert. We need more experts on networking, on all parts of information security. We're always learning. So if it seems overwhelming at first, that's fine. It was for me back in 1823 when I was a young kid. But stick with it. This is the very, 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 very basic, but uh, it's a fascinating world. It really is.
I agree. Well, thanks everyone for tuning in tonight. We'll see you next week, and
What are we talking about next week?
I'm not entirely sure. I think
We're going to
we'll.
do some packet capture, if I'm not mistaken.
Yes, we are. We're gonna take and look at some actual network traffic. We're gonna look at some packets. We're gonna see what when one IP connects to another and they start passing information back and forth. What does that look like? What's being transmitted across this protocol?
Yeah, and that'll be fun, man, because some of the things that you covered in the last episode with the OSI model, we can take the things that we see in the packet, map it directly to that OSI model. So now it starts to make more sense. And then also the same things we're talking about tonight, the TCP IP and IP addressing, you'll be able to see that right in the packet capture. And oh, okay, now I see how the computer is actually using that on the network. I think it'll be fascinating. And the challenge will be getting through it in 15 minutes.
Well, we may run a little long on that one just to make sure we cover it because it is so fundamental and foundational to security. So, thanks everyone for tuning in. We'll catch you again next week.
See you next week.